welcome. In this video I'm going to show you guys how to program one of these INA226 modules. And while we're at it, we're going to look at how to run a display as well, because usually you'll want to display the data locally and not send it over as serial. So this is all quite straightforward with a few tricks. First of all, you'll need to wire up the communication to the display and INA module. And this is done over I2C, so we have two wires, serial data and serial clock. They're marked SDA and SCL on both the devices. And on the Arduino, they're actually pins 4 and 5. So 4 is serial data and 5 is serial clock. Yeah, for the power, I think both of these accept either 3 volts or 5. So 5 they accept for sure, which is why I just went with the 5 volt out. And few tricks with the wiring. You'll have to bridge the ground on the measured circuit, so the high voltage, high amp ground with the circuit ground, with the Arduino ground. And this is done by this wire here. So I don't know if you can see the traces. Right, so you can see these two traces, and I'm basically taking the N minus and bridging it to system ground, kind of. And secondly, if you want to measure the voltage as well that's on the bus, you'll want to take a wire from VBS and connect it to the positive output of your supply and of the high voltage supply on the circuit that is being measured. So connect VBS to plus, to supply plus, and make sure this is sitting on the low side of the circuit. So to make this a bit more clear, let's jump on over to the computer, and I'll show you guys a quick schematic on this. Alright, so this is how it looks. Excuse the crudity of the design of the schematic. So basically we have the VCC and ground common with the Arduino, and this would be the 5 volt supply and this would be the high voltage supply. So you have the negative supply going through the current shunt, which by the way in this case is 100 milliohms, but we will discuss this later in the code. It is then going to the load and back to positive, right? And so yeah, what you want to do is connect the VBS to supply positive and also merge the ground of the supply with the ground of the measuring system. So this will give you quite an accurate reading, as we will see at the end of the video when we'll do the demo. So first things first, we're going to want to download 3 libraries for running the display and the INA. For the INA module, there's 3 libraries, 3 more common libraries. This one is the best, and the guy is working on it quite actively. This one I found to be the best, right? So click download zip, and next we're going to want to download a library for the SSD1306 chipset, and this is the chipset that's in most of the OLED displays. At least as of 2017, and so we're gonna take the one from Adafruit, to which we are very grateful, and also the Adafruit GFX library. So this is gonna allow you to draw stuff on the display, like rectangles and whatnot. And I think that is pretty much all. So now let's install the libraries. So this is quite straightforward. Just unzip them and copy them to the Arduino libraries folder. So this is going to be on Windows, this is going to be My Documents, or I don't know how it's called right now, Documents, Arduino, and then here you're going to have all your sketches, and then there's going to be one folder called Libraries, and you just want to copy these over here. Make sure you don't copy them in one folder. And that is pretty much all. So now you've installed the libraries, and Arduino can actually be running, and it'll still work. And I believe now we can go to the code. So let's start. So you're going to want to include these 4 libraries for the display and this one for the current monitor. Everyone seems to do this. So when you declare this OLED reset 4, I'm Honestly, not sure what exactly this does. I didn't have time to look into it, but yeah. You could, in theory, just write 4 here, but I don't know if something else uses this, but yeah. So first of all, we're going to declare an object of type Adafruit SSD 1306, and this object is going to be called display, and we're giving it the parameter 4 as a reset parameter, I would assume. And then we're going to call this object, so this can be called anything, so you can call this my display, for example, or absolutely anything. I named it capital D display, just differentiated a bit from some of the commands. Next up, we're going to declare an object for the power monitor, and this is called INA226, mainly because the guy used it in the Zanshin guy used it in his example. But this again can be called power monitor 1, for example, if you have multiples, or yeah. So these are the 2 objects. Then we have some variables. These will become apparent. Their purpose will become apparent later on. Basically, these are reading the actual values. So raw voltage is measured in unsigned int, because this can measure only positive voltages, the INA226. Current is measured in int32 because it can measure negative currents, and raw watts as well as only positive. I'm initializing the variables with some weird numbers just to notice if later on they're not changing, so I don't know. Then we have some strings which we'll use later on to condition the numbers, so you can't really do floating point division here, and we're going to do some string operations. I'll show you guys later. Alright, so the setup is quite simple. We're going to set up the display. So again, this is the command you'll want to write, which initializes the display to address 3C. If you've changed it on your display, go ahead and change this one. This is the default one, and on the ones where you can change the address, I am quite sure it's 3C on all of them. Alright, and we're going to run display and wait a bit. This will show the Adafruit logo, and yeah, why not give them some airtime, because they did put in all the work to get this running, and it's a very nice library, so I do enjoy it. We're going to clear the display. We don't want the logo to stay on it. Just as a quick side note, whatever you so you'll want to write something, and then you want to hit display, kind of hit like enter. This will go onto the display, and then if you display something else next to it, the original thing you display will not go away unless you say clear display or right over it, kind of. But you guys will figure that out. Then we're going to initialize the INA module. And yeah, so this accepts kind of a maximum amps reading. I'm not sure what exactly this does. The INA226 I have, given that it has a 100 milliohm resistor, will only be capable of measuring 819.2 milliamps. And yeah, so we're going to set the averaging. So this will take 10 values and average them and give you a bit more of a stable reading. These will basically maximize the conversion time, so should yield the best values, most precise values, let's say. And then yeah, there's some modes. If you want to check what all the libraries do, feel free to go to the Git pages and check out the .h files. So this should include all the files. This Zanshin guy has a very cool way of writing, and like it's super organized. I do love him. So if you see this, kudos, you're awesome. Alright, so here are the modes that you can use. Continuous bus, shunt, down, whatever you want, right? And you can put those in and all the other stuff. So yeah, this is very nice. All right. So what else is there? Not much. So now we're basically done setting everything up, and we can start with the loop. And this again is very simple. So this is the entire loop. It fits in one screen. And what we'll first do is save the values from the sensor, kind of. And as we've seen, this is 32-bit int. This is 16-bit unsigned int. And again, you could just declare all of these as int if you so please. So now we have these values, right? So what we want to do is, again, right, you might want to display microamps, but I find milliamps to be a lot more understandable, and I could put the comma and also show the microamps part, which is exactly what we're doing. So current is a string file, is a string type, and we're going to feed the raw current data. So this is an integer number, this is a number. We're going to tell the string function constructor that it's a decimal type, and this whole thing, right, this whole thing is a string object now, exactly as current. We're going to feed this into the divide by 1000 function. And this I have defined over here. And again, this is a bit longer, but again, I do use a lot of spaces. Yeah, so basically we have an output object. Where is it? Right, which is a string of length 8, and this is kind of the minimum you want to go for. We're going to delete everything that's in it. So since that is a global variable, and again, I would highly recommend using global variables. So instead of saying string output equals, I think you have to say string of this, although I'm not sure what the constructor is. I would assume so. So instead of declaring an object, a new object named output of type string every time you call divide by 1000, it is much better to just have it declared globally once at startup over here, and then just use it and override it and clear it, right? It takes a lot fewer steps, and given that this is a pretty weak microcontroller, I don't know, it's best practice to not have to declare stuff in local functions. Anyway, so we might get a, right, so this input will just be a number, so it will look like kind of like, let's say, minus 312, 421, right? And let's say this is microamps, right? It's not going to include microamps. So input can be equal to this, right? Let's assume. Let's actually make it negative, right? So we get more stuff going on. So now our output object is empty, and again, if I'm going too slow, then feel free to skip forward to the end of the video where I'll be doing the demo. So if we find a negative, we're going to put it into the output using the concat function. These are all part of the string class, and we're going to delete it from this, so it's going to end up looking like this. All right, this is quite simple. So what's happening here is we check how long this is. So if this would be just 2 characters long, for example, then we wouldn't need to put a separating dot for the decimal points. But if it is, for example, 6, we will need to put a dot kind of in the middle here. And so yeah, if case is 1, then 1 will go to 0.001. 2 go to 0.12, 0.012, 0.123. So this is basically all that this does. Is it takes the first number, puts a dot, and then takes the other 3. And yeah, that is pretty much all this does. I will not go into further details. Yeah, and that is pretty much all. So now that we have these current and voltage strings that look nicely, so current will look like, for example, minus 23.452 milliamps, and this might look like, let's say, 0.125 volts. Is it volts? So millivolts by 1000 it is volts. Alright. With the watts, this again is in microwatts, and I also don't want it to display milliwatts. So I do want actual watts to be displayed. And what I'm doing is I'm putting this into a temporary string, which will include the microwatts figure, which is going to be pretty long. It's going to be 9 figures long. I'm going to cut the least significant 3 numbers and throw them away. I really don't need that precise of a measurement. And then I'm going to feed it again through the temp function. And actually this is not needed anymore. So this was used in a previous implementation, now it is not. Because I'm throwing away the decimal points. I'm not using this function twice. We won't get into the details why. Alright, so now we're getting to actually displaying stuff. So now we've read the measurements in this case, in this part, and now we're going to display them. And we're going to do this every 20 milliseconds. It's going to take a lot more for the measurements because we're doing 10 averages, but doesn't matter. And just keep that in mind. This whole loop is not going to take place every 20 milliseconds. It's going to take place every, I believe, 30 or 40. But yeah. So first you want to set the size. And set text color white black. What this does is lets you overwrite stuff. If you don't include this black part, it'll just write on top, and you're gonna get like basically a white square where the letters were used to be, because it's just gonna write on top of it without removing the pixels that were turned on for the previous letter. But you feel free to try without the black, and you'll see what I mean. Then we set the cursor, and these are pixels. So and this is the x-axis, and this is the y-axis. So, alright, so now that we set the cursor, then you can start to print stuff. And what this does is basically fills in the buffer, the display buffer, with the values that you feed it. So basically in the buffer now, for the pixels 0, 20, we're going to start writing the value of current, which is a string of length maximum 8. After that we're going to, and this continues on kind of, so normally. Then we're going to print milliamps and a few white spaces, and since these have a black background, so the lettering is white and the background is black, then it's going to erase everything. So if you have a long value and then a short one, it's not going to leave stuff behind. And we're going to do pretty much the same thing for voltage and the watts. And at the end, you have to hit display. So basically what this does is it sends the contents of the buffer, which we've made to show current, voltage, and watts with some text after them. And it's going to send them to the display. And yeah, that is pretty much all there is to it. And now let's go for a quick demo and we'll be done. So yeah, let's turn it over to the table. And yeah. So first of all, we're going to power the Arduino. If I can get the wire. All right. And so we're going to take, as in the schematic, we're going to take power ground, supply ground, and connect it to in negative over here. Then we're going to take that over to a burden resistor, so which is this one here. So we're going to take it to the resistor, and then the other part of this will just go to the positive end of the supply. All right, and we're already getting some data. So I have my adjustable power supply here, and we can go up to, as I mentioned, 818 apparently milliamps. So as you can see now, we don't have any voltage, right? Because we haven't connected this this extra VBS wire, and for that we will just need to connect it to the supply plus. And once we have done that, we're going to get the voltage and going to be able to compute the watts. And this is quite accurate. I did check this with a Fluke multimeter and it does check out. So not too bad. And so that's pretty much all. Thanks for watching, and if you have any questions, feel free to ask in the comments. Have a good one.